Imagine you're having to do political polling right now trying to figure out whether Donald Trump or Mr. Joe Biden's going to win the election. You can imagine the questions you ask are pretty easy. Who do you support? Things like that. I'm doing a survey. It's not that easy either. Actually, the hard part of polling is figuring out how to treat the responses, because it's more complicated than you probably think. For one reason, you're trying to use a sample to say what's going to happen in the whole country, and your sample is never exactly like the whole country, and your sample is never exactly like the people who vote. And so whenever you get these survey responses back from people saying, I'm going to vote for Trump or I'm going to vote for Biden, you got to figure out, how do I treat that response? There's a science behind it. There's also a delicate art behind it. And I'm going to give you just a glimpse of some of that in regards to gender. So what we have this worksheet here. And I don't know if you remember Proposition 777, but that was a proposition that was on the Oklahoma ballot regarding, it was a measure that would be put in the Constitution. It passed, kind of saying farmers can do whatever they want. They can use any kind of technology they want. And like no rules can be passed against them and stuff. And it was very contentious, and people were trying to figure out whether it would pass or not. It didn't pass. But what we're going to do is we're going to pretend like we did a survey before then, trying to figure out whether it would pass and stuff. But let's suppose we did a survey where we were asking people before, maybe 1 month before it's going to be on the ballot, whether they would support the measure or not. Suppose we get, I've only got 10 responses here because I want us to do this by hand to really understand this thing called weighting. But let's just suppose these 10 responses represent like 10,000 people, where one response represents 1,000 people, something like that. And we have respondents here, and we have 4 males and 6 females. The 3 of the males said they were going to, when we asked them how they plan to vote, they said they were going to vote for it. 1 male said they were going to vote against it. And then for the females, we're going to say 2 females said they were going to vote for it. 4 said they were going to vote against it. I just made that up. It's hypothetical. Ignored that last column, did you vote in the last election? But that's something we'll come back to in a minute. Katie, I'm so sorry. I must not have made... I'll give you my key at the end, though. So sorry. We have such a big attendance today. How was I supposed to know this many people were going to show up? Okay. Okay. And so what we're going to do is we're going to look at our sample. We're going to look at what the population looks like and say, do we need to adjust any of these numbers to account for the fact that there's more women than men in the sample? So number 1 says, what is the percent of females and males in the sample? So for males, 4 out of 10 were males, so that's 40%. And for females, 6 out of 10 were females, for 60%. So the sample was dominated by women. This is something you commonly encounter in surveys because women are more willing to take surveys than men. Men are hampered by the lack of opposable thumbs and cranial capacity. Okay. But then if we look at the actual population of Oklahomans, we see that, well, there we go. Number 2 says, what percent of the respondents say they are for the proposition? Well, if you count up all the 4s, there are 5 for the proposition out of 10. So 50% of people say that they are for it. But what we're doing next is we're going to say, okay, there are more women than men in this sample, and if you look at their voting patterns, the women were more likely to vote against it, men were more likely to vote for it, but in the population of Oklahomans, the ratio of males and females are basically the same. It's like 50.8 females because females live a little longer. And so this sample's biased. It doesn't represent the population because it overrepresents females. And so what we want to do is we got to figure out, so we don't want to just, this is like a simple average of how many of the sample respondents would vote for it. The simple average says 50% would vote for it, flip a coin whether it will win or lose. But we need something different. We need a weighted average because in this sample, females are overrepresented. So what we need to do is we need to come up with some kind of weighted average where the males get a little more weight than the females such that the voice of the males gets the same amount of emphasis as the voice of the females. And every poll corrects for things like this. They not only correct for gender, they correct for ethnicity, they correct for income, they correct for geographic distribution, a whole bunch of stuff. We're just going to look at one way of correcting for these things. And by the way, almost every time I do a survey, I do things like this. Okay. So what we're doing is we're going to be calculating a weighted average. And I know you did a weighted average in 3213. I also know you've forgotten everything in 3213. So we're just going to relearn it all again. And so number 3 says, let WI be the weight placed on individual I. And let the weighted percent of people for the proposition be calculated as follows. All right, so what I'm going to do. So well, let me say it this way. We just have this table here that I'm going to be using a lot. So I'm going to we've got some variables. I'm just going to do the columns a little different here. One, we have this one variable, an indicator variable, x1. Xi just equals 1 if the ith person said they were for the proposition and 0 otherwise. And this is going to stay the same throughout. So the first 3 males said they were for it, so they get a 1. And you can go ahead and start filling out your column there. The 4th person said they're against it, so 0. 5th and 6th said they're for it. So the indicator variable equals 1, and then the rest said they're against it. And then we have, okay, we're going to, every average you ever do, remember that 5 divided by 10 where we said 50% of people voted for it? That was a weighted average. Every average is a weighted average. It's just that the normal average you're used to, the weights are 1 for everybody. And so it gives you this formula here, weighted average, where you sum over all the i's. Wi is the weight given to the ith person. Xi is 1 if they voted for it or not. I know you've done the summations before, but you might have forgotten. That's okay. We're going to do the summation out to remind you what it is. The first thing we start with is number 3 says, suppose everyone receives equal weight. So that's what we do when we just look at the sample average. We say every female in the sample gets the same weight as every male in the sample. So in this case, the weight for every person, where I refers to the person, so first row, this would be W1, W2, W3. Everybody in the sample gets equal weight. And of course, what we're eventually going to do is we're going to change these weights. We're going to give a bigger number for males, smaller number for females, because males were underrepresented in the sample. All right. All right. And when we do a simple weighted average like this, all we're doing is, so this is like W1 times X1 plus W2 times X2 all the way to W10 times X10. The sum of WI just means W1 plus W2 plus W3 all the way to W10. So when we calculate this numerator, we're just going W1 times X1 plus W2 times X2 plus W3 times X3 plus W4 times X4 plus W5 times X5 all the way along. So we're just going this times this plus this times this plus this times this plus this times this plus this times this all the way down. And so when we do that, 1 times 1 is 1. 1 times 1 is what, Lauren? 1, that's right. 1 times 1 is what, Drendel? 1. 0 times 1 is what, William? 0. There you go. And we'll just keep going. We have 1, 1. And then zeros the rest of the way. And then the numerator, you're just summing each of the weights, W1 plus W2 plus W3. So go 1 plus 1 plus 3, 6 plus 7, 8 plus 9 plus 10. So that's all these summations are doing. And then we say, well, the numerator, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 50%, the same number we got before. So again, that's just saying when each person in the sample is given the same voice, is weighted, they're same, when their opinion matters the same as everyone else, we say 50% of people in the sample are for it. Same thing's for it. So all I'm doing with that is just showing you that every average, every percentage is a weighted percentage. It's just the simple ones we're used to, each observation counts equally. But Drenda, we don't want each observation to count equally, right? We're tired of people like Lauren, her voice outweighing ours because they are answering surveys and we're not. That's right. No, the electoral college is so we can cheat. All right. So what we got to do now, so we got to figure out how to make Drendel's voice bigger and Lauren's voice smaller. Not because we don't like Lauren, not because we like Drendel. Nobody likes Drendel. It's just it's just that we want this sample to represent the population. That's all. So what we're going for is we're going to number 4 now. And what we want is we want different weights for males and females. And I'm just going to give you the simplest example of how we can do weights like this. So we want to, instead of giving everyone weight of 1, we want males, each male to be given one weight, each females to be given one weight. But we want to do it such that it appears like the voice of the males is equal to the voice of the females. So let me start with this. So, right now, the number of females divided by number of males is 6 divided by 4, or 3/2, 1.5. More females than males. But what we want is we want this ratio to appear like the number of females and number of males are equal. We want to do weights such that when we do a weighted ratio, they're equal, meaning the weighted ratio of females to males is just 1. Well, notice to make 3/2 1, we have to divide by 3/2. That's one way to do it. And males is on the bottom. So just note, what if we do this? What's that? Yeah. Yep. No, we are number 4, yep. A weighted ratio would take the weight for females times number of females divided by the weight for males times number of males. We want this to equal 1. Well, this is actually pretty easy. You know this ratio is going to be 3/2. Well, if we just make the female weight 1 and the male weight 3/2, that'll do it for us. So females, same weight as before, but the weight for males is 3/2, 1.5. So the voice of each male is going to count 50% more than the voice of each female. And that should make sense because there are 4 males, increase their voice by 50%. That adds 2 males. That makes 6 virtual males. There were 6 females. So now it's like we magically made this sample representative, equal in males and females. So if we do this, the weighted ratio, 1 times number of females, there was 6 females. Weight for males was 3/2, number of males was 4. 3 times 4 is 12. 12 divided by 2 is 6. And this is like you were texting the word weight. Weighted ratio is now 1. So now using these weights, the voice of the males carries the same weight as the voice of the females. And by the way, just a quick aside, if you did a survey and like 65% of your sample were Democrats, well, then you would be over-representing Democrats because Democrats are probably 55% of the population, not 65. And so you do a weighting procedure where you give conservatives a bigger weight, Democrats a smaller weight, to make that sample sound like the actual distribution of liberals and conservatives. Only if you did that could you say your poll was representative of the nation. And so you can see right away there's lots of little things you can do in polls if you don't have integrity to make them misleading. That's why generally you only want to really look at polls from organizations that have a reputation to lose, like major news outlets. Not all major news outlets, but people who seem like to have integrity. magazines like The Economist, things like that. InfoWars, of course. Yeah. All right, so now we're doing number 5, and we're going to calculate our new prediction using weights. So we've got this table again. And our new weights, remember our first 5 observations there were males, so we're giving them a weight of 3/2. And all the females get a weight of 1. And now our new weighted percent for, you have the same formula over all I people, the weight xi times wi divided by the sum of the weights. So I'm looking here, we've got, going for the first males, we have 3/2, the weights for the males, and there were 1, 2, 3, 4 males in favor of it. The weight for females is 1. There were, there were just 3. Yes, right. Oh, and so, yeah, so this should be 1. Thank you. And then the weights for females is 1, and there were only 2 females in favor of it. So 2. Down here at the denominator, we're just summing up all of these. And so we had 3/2, 1, 2, 3, 4 times. And then we had the 1s, 1, 2, 3, 4, 5, 6 times. So we have like 9 divided by 2. Now we calculate that 54% are in favor of it. So again, what we did, we had this sample where females were overrepresented. And in that sample, only 50% were in favor of the referendum. That was a problem because there were more females than males in the sample, but in the population they're the same. So we did this thing called sample balancing. That's the answer to number 6, is just sample balancing, S-A-M-P-L-E, balancing, B-A-L-A-N-C-I-N-G. We give males more weight than females. And when we do that, we find that more people are for it than against it. So whereas before we said flip, it's a toss-up, it's a dead heat, whether it would pass, now we're saying it would pass. And when you do surveys like this, you have to account for things like the people with a college degree are more likely to answer a survey. You have to correct for that. Another thing, and this was going to be the second, we're not going to do number 7, but another thing you want to do is notice that in the first table, we also asked them, did you vote in the last election? Some said no, some said yes. If we want to know the actual outcome of an election, sometimes we want to predict who's actually going to vote or not. And so we can ask them, as long as they're like, could have voted in the last election, we say, did you vote in the last election? And they said yes. Maybe we give them a bigger weight than people who said no, because they're more likely to vote in the next election. So that makes polling even more tough, because not only do you have to ask people these questions, you have to figure out whether they're going to vote or not. You got to predict whether they're going to vote, and that's hard. And that's one thing that makes polling so, so hard. Who wants some good news? Was that a yes or okay? For one of your homework questions, since you're here in class and you've been writing it down, you too, Katie, you get full credit. Don't have to do anything. Everybody else, they got to upload their answers that they did here. How you like that? Aren't you glad you came now, right, Lauren? Yep. For you at home, well, sucks to be you, I guess. Boo! Okay, it's the last time I'm here. What's that?
I don't think that lectures
Yeah, anybody ever watch Conan? And he would always do that with the camera. He'd go down and sneak up. Y'all got to watch more TV, all right? Y'all probably just watch reality shows, don't you? Well, Hallmark Channel for you, probably.
Every other day. It's in between the networks.
Okay, we're going to do just going to show you some. Don't worry, Lauren, we're going to get out of here quick. I'm going to bring you back to a simpler time in American politics when it wasn't so nasty. And some of the things you would see in the news would be about some legitimate issues. First, I want to show you, remember how we talked about very misleading survey questions and how a lot of times when you get survey questions from a political party in the mail, they're ridiculous questions. Remember my question like, is Putin a great president or the greatest president? I'm going to show you an example from some of those.
I love polls.
Notice anything odd about this inaugural year approval poll from the GOP? Respondents can rate Trump's first year as great, good, okay, or other. When asked the same question about President Obama, there's a fifth option: poor. Now, this isn't the first time that Republicans have sent out polls with suspicious questions. In March 2017, the GOP polled to see who stood with the president. There were two options: I stand with President Trump, or I believe Democrats and fake news. A September 2017 poll on presidential approval did offer a simple yes or no response, but there were a few additional items tethered to Trump, including the American flag, our country, and unspecified heroes. Conservative pollster Frank Lunt says that surveys like these are completely unscientific.
There's nothing authentic about it. It is simply a method, a technique to engage people, to make them feel like they're being heard, and in the end, perhaps even raising a few dollars. As a fundraising technique, it works. Republicans use it, Democrats use it, and we all know what it's about. It's about fundraising, not public opinion.
The practice of using surveys to collect voter information is so common that political scientists have a name for it.
It's fake polling, but the jargon of the industry is sugging.
Sugging can have an impact on the way people perceive polls, both real and fake.
It's setting the wrong expectation of what a poll is for people. You just throw your hands up and say, all polls stink, I don't need this.
Both parties use polling in their outreach because it's an effective means to their end: personal data collection, and hopefully, fundraising. Political bias in these surveys is nothing new, but examples like this are especially egregious. It's impossible to find the results of these polls, and the GOP didn't respond to our numerous requests for comment about the data or how it's being used. So why bother making a poll that literally can't make you look bad if you never plan on releasing it? Maybe it's to excite your base, or maybe you have a different audience in mind.
Some of the polls are great. I only really acknowledge them if I'm winning, so don't worry. And by the way, we're winning in a lot of polls.
Now, this next one actually has to do with the weighting thing that we're talking about. It's kind of a mock, a farce of it, but that's the whole issue. Did any of you watch the Late Night with Colbert, Stephen Colbert? I don't know if he knows, but before this, he had the Colbert Report, the funniest show that's ever existed. It's basically where he played it was like Tucker Carlson satirical, a farce of Tucker Carlson. So he's pretending to be conservative, but he's doing it in a funny way.
You can't trust polls, right, Fox News?
The latest Fox News polls give President Obama an edge in 3 key swing states. He's up 5 in Florida, 7 in Ohio, and 7 in Virginia. But that's with all likely voters. Once you isolate voters who are extremely interested in the election, the race is much closer.
Yes, much closer among the extremely interested. And Romney's tied when you focus on the inexpressibly intrigued. And he's up by 2 points when you count only voters who are psychotically engaged. The point is, the polls showing Romney behind have to be wrong.
We have a bunch of polls, Gallup, Pew, and the CNN, which either oversample Democrats or, at least in the case of CNN, appear to grossly underestimate the percentage of independents.
There's really lousy sampling in these polls.
I don't believe them because I think the sampling is probably skewed.
It is clear that many of these polls are oversampling.
The polls are skewed. Look, I don't believe them.
Neither do I.
Look, you can go through all the scientific gobbledygook you like. I don't believe them.
Yes. They're basing this all on scientific gobbledygook, which is also the name of Stuart Varney's character in Harry Potter, Professor Poppycock Gobbledygook. That's very hard to say without swallowing your own tongue. Now, luckily, folks, I've got my own source of polls, conservative blogger Dean Chambers, who analyzed these polls favoring Obama and then reached the scientific conclusion that they just didn't look right. So Chambers set up his own polling site, unskewedpolls.com, where he unskewed all the national polls by skewing them in favor of Romney, and surprisingly found that Mitt actually had a nearly 8-point lead. And that doesn't even count the margin of error. And given how many errors Romney's made, I think he should get all of it. Now, no surprise, folks. This feels accurate polling has caught the attention of some GOP intellectuals like Texas Governor Rick Perry, who tweeted, "Always nice to get unfiltered, or in this case, unskewed information. Amen." If we had only had more accurate polling during the primaries, Perry could have dropped out way sooner. And folks, Chambers' work throws all polls into doubt now. Even the internal ones I've taken of myself. I mean, the results say I'm not that excited about Mitt Romney, but as a conservative, I feel like I should love him. I mean, maybe the sample size is too small, or maybe I checked the wrong box and I'm actually Latino, you know? Quien sabe? Thankfully, Fox News is fighting back with its own fair and balanced polling.
We asked you tonight, who will win Ohio? 10% of you said President Obama. 90% of you said Mitt Romney. Thanks for your votes. We had more than 20,000 of them tonight.
I don't know. That poll looks like it oversampled Democrats by 10%. Well, folks, I am so inspired that tonight I am conducting my own properly weighted poll. So go to colbertnation.com and make your voice heard by answering this question. President Obama currently leads Mitt Romney in the polls. Why are polls so skewed? A, people tend to choose the first option they are offered. B, I don't answer polls. C, when in doubt, always pick C. Remember, This is a scientific poll in that the results will be tabulated by a lab chimp. We'll be right back.
So one good thing about going to college and attending lectures like this is that, you won't remember the weighted procedure that we did and everything, but, hopefully taking away there is a proper way of doing polling and surveying. There's also an improper way, and that just because one is bad, one poll is bad doesn't mean all polls are bad. You've got to look at the institution doing it and saying, do they have a reputation that they're trying to protect? Is their mission to actually provide factual evidence, or is it something else? And usually smart people like you can figure out the difference pretty easily. Okay, this is my last time here, and let me talk a little bit about Exam 2. I was starting to make Exam 2, and, I've covered a lot of stuff. And if I asked everything about we've covered, especially since we haven't been able to crunch numbers together, usually in a class, we'd have our own laptop and we crunch the numbers together and we have more practice with it and stuff. But we haven't been able to do that. And so I felt like the test was getting a little too hard. And I started getting nervous about you not liking me, and I'm too insecure of a person to have that. And so then I said, well, what's a way for me to still make sure I cover some of this information while also making the test more reasonable? And so 2 parts what we're doing. I'm going to release a video either end of next week or beginning of next week where I'm actually tell you what's on. It's going to be a take-home test just like last time. I'm going to describe what's on the test. I'm going to give you helpful advice for answering it. I'm going to put more pressure on you to do better on the essay questions. But then there's going to be 2 questions where if you were in class when we did it, you automatically get full points. If you were not, all you have to do is take the worksheets, watch the video, give the answers, and I've got a place online when you could upload it. And those 2 are, one of them is the thing we did today. So if you're here today, you get full credit on that. For those of you at home, you just have to watch, you've watched this lecture. If you've already, I guess I should have told you this before we did the lecture, but you should print out the worksheet and just put in the answers just like we did here, and then you'll upload it and I'll check it. And so as long as you're doing what everybody else here did today, you get full credit. The other one we do is the regression that we did last time. I'm doing that as well. So Lauren, you're going to have to watch that video, and you're going to have to do the answers. All right. And you'll see at the end we didn't know if we should leave or not because you were not here to tell us. Okay. And you have to do the regression, put all the answers, and you just upload it and you get full credit. We also did the sign test, but there's going to be a question on the test about the sign test. And so I'm going to have a video about the exam. I'm going to release the exam sometime soon. I'm going to give you like 2 weeks to do it. And so as long as you're willing to put forth some work, you shouldn't have any problems. And I'm also going to put together a very short video with some kind of final remarks about the paper. What I'm going to do is we've talked a lot about the paper, but I've just got one document where I'm summarizing what we've said and where to go back into the lectures you remember there was a lecture where we talked about what the outline should look like? I'll remind you where that is. There was a lecture where we talked about how to discuss the Nielsen's, 12 steps in product success. I'll remind you where that is so you can go back and look at it, and I'll give you some final little things about what kind of font it should be. What kind of font do we use in this class? Garamond. We only use Garamond. All right. This is an elite institution. We use an elite font. All right. And then, you know, normally what I do is at the beginning of Dr. Van Overbeek's stuff, I'd come in and check in with people, but a few people are here. So I think what I'm going to do is just require you sometime before the end of the semester to make sure you've chatted with me either in person or in Zoom about the project at least once. And part of that reason is there's been a lot of students I've just never gotten to meet, and I want to say I've met you at least once, and there's some of y'all, I don't know what you look like without your mask on, and it'd be nice just to be able to recognize you in public, you know. And that. How's that? Is it too early to just quit now? I mean, can we just call it quits right now? Lauren? Okay. Okay. I'll see you on Zoom or in person. We'll be in touch. Of course, you know you can contact me anytime. I wish we didn't have to have our class like this, but at least we got to do some things together.